In this video, I'm going to explain like terms in two different ways. The idea of like terms is actually really simple. After all, like terms are basically just terms that are like each other. But take a look at these examples. I think these examples make everything a lot easier to understand. Let's say I have 3 2s, and let's say I have 4 more. These are like terms. Like terms. Why are these like terms? Well, because they're both telling us how many 2s we have. They are like each other in that way, so we call them like terms. But let's say we have 3 2s and we have 4 1s. Well, then these are not like terms. These are not like terms. Or we can call them unlike terms. Why are they unlike terms? Well, because one is telling us how many 2s we have, the other is telling us how many 1s we have. They're unlike each other in that way, so we call them unlike terms. You can also do this with letters, right? Which it's not surprising that people do this with letters, right? Because remember that in algebra, letters are supposed to be numbers, right? We use letters to represent numbers that we don't know, right? Letters are supposed to be like mystery numbers, right? So it's only natural that if people are doing this with numbers, then they would also, start doing this with letters as well. So let's say we have 3 x's, and let's say we have 4 x's. And I could write this like this, I guess, apostrophe S, but people don't actually do that in the world of math, right? If somebody wanted to write 3 x's, they would just write 3x. If somebody wanted to write 4 x's, they would just write 4x. Anyway, if we had 3 x's and 4 x's, those would be like terms. Why would they be like terms? Well, because they both are telling us how many x's we have. They are like each other in that way, so we call them like terms. But let's say we have 3 x's and 4 y's. Well, then these would not be like terms. These would not be like terms. Or we could say they are unlike terms. Why are they unlike terms? Well, because one is telling us how many x's we have, the other is telling us how many y's we have. They're unlike each other in that way. So we call them unlike terms. I think you're starting to get the hang of this. Let's look at one more example that has like more letters involved. So this is 3x squared y cubed. So basically, we have x squared y cubes, and we have 3 of them. Okay, and let's say we have 4 more. These would be like terms. Why are they like terms? Well, because they're both telling us how many x squared y cubes we have. They're like each other in that way, so we call them like terms. But what if we had 3x squared y cubed and 4x squared y to the 5th or something? Well, those would not be like terms. Those would not be like terms. Or we could call them unlike terms. Why are they unlike terms? Well, because one is telling us how many of one thing we have, but the other is telling us how many of a different thing we have, right? So the terms are unlike each other in that way. So because x squared y cubed and x squared y to the 5th are different, right? The fact that the exponent is different, that matters, right? These are different. So yeah, the two terms are unlike each other in that way, so we call them unlike terms. Okay, let's see what happens when we try to add these things. Well, if I do 3 2s plus 4 2s, I get, well, 7 2s, right? 7. Okay, that was pretty easy, right? We basically just did 3 plus 4. Okay, what's 3 2s plus 4 1s? Well, is that 7 2s? No, because we only have 3 2s. Is that 7 1s? Well, no, because we only have 4 1s. So this is not as simple. we can't just do 3 plus 4 and get like the correct answer. Okay, what about 3x's plus 4x's? Well, that would be 7x's in total, right? That's really simple. We basically just did 3 plus 4. What about 3x's plus 4y's? Well, is that 7x's? No, because we only have 3x's. Is that 7y's? No, because we only have 4y's. So this is not as simple. We can't just do 3 plus 4 and get the correct answer or something. Okay, and then let's do these as well. Let's add these as well. So 3x squared y cubed plus 4x squared y cubed, that will be 7x squared y cubed, right? Because basically this is saying 3 of a thing plus 4 of a thing is 7 of the thing, right? But what if we have 3x squared y cubed plus 4x squared y to the 5th? Well, now we're adding different things. So that's not going to be as simple. Is that going to be 7x squared y cubed? No, because there's only 3 of that thing. Is that going to be 7x squared y to the 5th? No, because there's only 4 of that thing. So yeah, this is not as simple. We can't just do 3 plus 4 and get the correct answer or something. So your main takeaway from this, hopefully, should be like terms are simple to add, unlike terms are not. Here's the second explanation. Let's say I have 3 2's and 4 more, and I want to add these. And like what's the final answer here? Well, okay, so 3 2's, that's like 6, right? 3 2's is 6, like, because you can think of it like 3 times 2, right? So yeah, so 3 2's would be 6, and then 4 2's would be 8, okay? And 6 plus 8 is 14. So the final answer is 14. Okay, there's another way you could do this problem though. Take a look at this. You can add 3 2's and 4 2's, right? Because in total, that would be 7 2's, right? Okay, and then how much is 7 2's? Well, it's like 7 times 2, that's 14. We get the same answer. We get the correct answer, right? So there are 2 different ways that you can do this. So this way here, where we add 3 2's and 4 2's, and get 7 2's. This is called adding like terms, adding like terms. And as you can see, it gets us the correct answer. So adding like terms is like literally mathematically correct. Like the math works out. Thanks for watching.